We are back, scientists. Welcome back for another science lesson. Great to see all the rainbows that you guys made last week. I have something special to show you this morning, today, this afternoon, whenever you're watching this. This isn't the original box, but in here is the ring that I proposed to my wife with, and it's a special sort of diamond. There it is. There's the little ring with the diamond. Took all my money. There is, let me first actually start with some of the colors that we're going to talk about, and then I'll explain this, because this is a little bit off topic, but it is interesting. And the reason I'm going to show you is, hopefully you can see this, when you put it under a special sort of light, it glows blue. Yeah, it's almost like it's blowing out in the video because it's so bright. But I can see it a little bit better there. It glows blue. And even some, this will probably be too small for you to see, but even some in the band, they glow blue as well. What the heck is going on? Why do we have this alien ring? Let me tell you all about it. Now, you might remember from last time that if you have a red object stuck in a box, blah, 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 blah. If you have a red object, that it is going to reflect red light. That's why it is red. So if you have a red object like that, we have light coming at it. But this light is not just clear or whatever. It has all the wavelengths of light. So when you write down stuff in your science book, year 5s, you can write light as the topic. Today is the 5th of the 5th. And the wavelength. And there are different wavelengths in the light that's coming at this object. There's the red wavelength, orange, yellow. Oh, that showed up okay. Not too bad. All the colors of the rainbow that you guys saw coming out refracted. Blue and I don't have a purple marker. But basically, all these wavelengths, I mean indigo or violet actually, technicality. All of these wavelengths, when they hit the red thing, some are being absorbed, some are being reflected. Bonus points if you know which ones are being reflected. The red one is the one being reflected. Say that this is my eye looking at it here, my red eye. This is my eye looking at it here. Wow. My beautiful eyelashes. That looks super weird. There we go. I needed more. Nah, still weird. Whoa. Here's my eye looking at it. The red light is reflected off the object into my eyes. It goes in that direction. The red object, the red wavelength of light is reflected off the red object and comes into my eyes. That's why we see it as red. And the rest are absorbed. So it's the same year 5s if we had any color you want. If we had a green one, and all the wavelengths of light are shining at that, let's have the light come from this direction. All the wavelengths hitting it because all of this is in one beam of light. And last one, indigo, last two, indigo and violet. If this is green, it's because the green light is reflected that way. Because year 5s, a lot of people do this. They think they'll draw a diagram like this. My eye still looks weird. I think it's because maybe I gave myself, I think I gave myself too many parts of the eye. Some year 5s will draw a diagram like this. They'll have an eye, and they will say, oh, I can see this tree. And the tree looks green and orange because the orange light, because I can see the orange and I can see the green. No, do not do that, because there's no light coming out of our eyes. Our eyes are not emitting light. Our eyes are receiving the light. We're seeing what is bouncing off it. Now, cool little thing that you maybe have put together already. All the light that is being absorbed, some of it is, it all is energy. This light is energy, but it's some of the wavelengths of light are more energy than others. I'll show you a diagram on the projector in a second. And if it is absorbing, if an object is absorbing all this energy, it might heat up. And we know that when we see something black, a black object isn't actually reflecting any wavelengths of light at all. The black object isn't reflecting any wavelengths of light at all. It is just absorbing all of them. Not a single wavelength of light is bouncing back from this, which is why black things get hotter, because they're absorbing all that energy and they're absorbing all that heat. So then, what about a white thing? A white thing actually reflects all the wavelengths of light. Every single one is bouncing off to let us see no color for that object. All the wavelengths are bouncing off, and so we see it as white. We don't actually see it as black. We don't see it as any color, which is interesting, hey? All right, if you've got some colored pencils, pause the video now and get this all down. If you don't, draw what you can, especially the fact that the color that bounces off is the color we see. In fact, you can write that down. The wavelength of light that bounces off an object is the color it appears to us. And in brackets, light does not come from our eyes. So there you go, year fives. Pause if you haven't already. Get that stuff down, and then I'll show you a few diagrams and explain what the heck is going on with this ring. My beautiful diagrams. And I'll put these up on the science assignment as well, year 5, to help you out. There's just a little bit extra of interesting stuff. we go. All the wavelengths of light that we can see. Let me turn the light off for you. So you'll notice that they have different energies. Some are higher or lower energy. And this is actually only part of what we can, part of light that we can see. It looks like this. Basically, sorry, it doesn't look like this. This is a symbol of kind of what it looks like. We can only see these colors. Dogs can see fewer colors than this, but we can only see these colors. And it's part of a bigger spectrum of light. Just like this. So we can only see, this is the only light we can see with these colors in it. So what you are seeing in this ring is more in the a different, it doesn't have like fluorescence up here, but basically the light that is being reflected from this we can't see with our normal eyes. So we need a special light to make it visible to us to see that it's blue and it glows. Ooh, that's a bit better. There you go, now you can see it glows. There you go. So this is light that is actually invisible to our eyes. We can only see it with a special torch. Interesting, hey? It only reflects this kind of light to our eyes. Our eyes can't see anything else. So there you go, year fives. Hope that was interesting. You will be able to see in today's activity an actual living demonstration of all of these colors being in the visible light that we can see. All right, have fun with that. I will see you later. Bye.